Welcome to Unit 2 of our mathematics lessons. And in today's lesson, we're going to introduce relations and functions. Relation and functions. I am Carla Michael. I'm your lecturer in this course. Now, when you talk about a relation, I want you to imagine, or I want you to think about factors that connect you with your best, your better half. Maybe your wife, your girlfriend, your best friend, or any person that you work along very, very well or understand each other very, very well with. Now, that's what we're talking about, relations. So there are factors that bring you together, and those factors are they are the factors that build the relationship. Now, depending on those factors, your relationship may either be stronger or weaker, but at the end of the day, there is a relationship. So because of that, we're going to look at relationships and functions. So let's define a relation in terms of X and Y. Now, when we look at that, a relationship has got what we call a domain, a range, and a function. Domain, range, and function. So this is what we're going to look at. Now let's define a relationship in form of X and Y. So when we have both X and Y, X is a set of ordered pairs that explains the domain. Y is the set of pairs that explains the range. Okay? So the first component is always a domain, and the second component is always what we call a range. So let's go on without wasting time. Let's go on to finding what we call a range and a domain. So for example, EG1, okay? Example 1, if we have, for example, if we got something like this, okay? If we have something like 3.2, 5.7, all right? Maybe we have 6.4, 7.1, something like that. Then we got 17.8, 0.4. Now, let's find, so the question is, find the domain and range. Okay? So it is as simple as follows, right? So remember what we indicated. We said the domain is always the first component, the ordered pairs, the first component of the ordered pairs, and the range is the second. So you do it quickly, let's see what you have. What do you have? Awesome. Alright, so we are going to have our range, our domain, okay? Our set of domains is going to look like, we'll get all these are the domains, right? So our answer will be, 0.2, 6.4, and 17.8, okay? These are our domain and our range, the second component, okay? So our range is 5.7, okay, 7.1, and 8.4, okay? So you will find this in the quiz, and don't fail this in the quiz because it's very simple. You can find answers by looking at. When you talk about domain and range, these are simple things. So a domain is always a second component of a domain is always the second component, always the first component of the arrangement, okay? So you shouldn't be able to fail to find the domain and the range, okay? Now, of course we know that the domain, okay, the domain and the range are two different things that represent different things different components or different parts of the work. Let's go on to something else that will help us to do this. So since we've understood what a domain is, we've understood what a domain is and the range is, let's now do the introduction to functions. Since we understand what domain and the range is, let's now look at functions. Okay, let's look at functions. Okay, let's look at functions. Functions. Let's look at functions. So, what is a function? Okay, this is a type of a relationship. Okay, a function is a type of a relation. Okay, so if we say x and y, okay, so if we say x is a function, x is a function of y, what are we trying to say? Okay, we are saying that what we are trying to say when we say x is a function of y, we are saying that for every element x in the domain, there is a corresponding exact one element in the y range. So what we mean is that when we say x is a function of y, we mean that every element in y, okay, every element in y, okay, every element in y corresponds with what? With an element in the x, okay, in the y. Every element in x corresponds with an element with y. So this is our domain, this is our range. So when we say x is a function of y, we mean that every element corresponds with another element in y, okay, which is the domain. Now, so to understand this is one of our examples. You have this is something like this. We got 1a, okay, then we got 2b, then we have 3c, okay, something like this. So this arrangement, we relate, when we map it, it will look something like this. This can be the answer to show that there is there is a relation, okay? There is a relation. So you can be brought, so for you to know that there is a relation or not, there is supposed to be, one factor for another. One factor for another, okay? So there's supposed to be one-to-one relation. So this is a one-to-one relation. Of course, there are also other type of relation, like one-to-many relation, okay? One-to-many relation and whatnot, okay? So basically, that's what we are talking about. So each relation is defined by by a certain type of relation. Okay, that's what we say when we talk about relation. Now, a good function is a situation where all elements in x are mapped to elements in y. So that's what we're talking about, a relation or a function. Okay. Now, without wasting much of time, now let's look at the function notation. Function notation. Okay? Function notation. What are we saying? This relationship in mathematics, this function relationship, a function is a relation with added restriction that each value in the domain must have only one corresponding y value in the range. Okay? So a function is defined as a relation with added restriction that each value in the domain must have only one corresponding y value in the range. So what we are saying, a function is that every element in the x must have only one corresponding value in the y. So meaning the element in the range must only have one value with the element in the what? In the y. That's what we call a function. And because of that, there's supposed to be one relation with two variables. So let's look at, for example, y is equals to 2x. Okay? So this is a definition of an ordered pair. Alright? So this is a notation that shows that y, it shows the relationship to say y is equal to 2x. Okay? So if we find x, it means we have found what our y is. Okay? To get our x. Alright? So that's what our ordered pair is. So when a function is defined by equation, we often use function notation. For example, this is representing a function. Now, the way you've seen this one, it's 2x. Now, in functions, to represent the notation, we say f of x, okay, we call it f of x. This is our f, is equals to 2x. Clear there? Hope you are not getting confused. So, for us to show that these are functions, in notations, we're going to say f of x. Okay? F of x, it means that there is a y there. Okay? That is invisible. So, when there is y, we put f of x. Alright? We put f of x, which is equal to 2x. Okay, where f is the name of the function, okay, x is the name of the function, okay, x is the name of f is the name of the function, okay, and the x is an input value, okay, is an input value. What we mean is that we need to find out the value of x. We need to find out the value of x to know what will give us x, or what will give us y. So, x is an input value from the domain of the function, which is f of x, the function value, okay? So, this is the value, an input value, which corresponds to y, to give us that very thing, okay? So, the notation f of x is read as f of x. So, this function, f(x) is read as f of x, okay? Okay, the value of f of x, the value of the function of f at x. Alright? So, let's now look at something that is simple. So, the function may be evaluated by, for example, let's say, e.g., let's say, what is f of x? Okay? What is this? Okay? At x is equal to what? 5. At x is equal to 5. So what we are trying to say is that what is the value of f of x to x if x is equal to 5? So here it makes it simple. So what we just do is we say x, we close there, then we go, then we say what we will do now is that this function will transform. So we're going to say where there is x we replace what? 5. What it means is that wherever there is x, we are representing 5. So we are saying, what is the value of f of what? F of 5 if 2 is equal to 5. Okay? You did, we did equations last in our previous section. This is very easy now. Okay, so our f of 5 is equal to 10. Okay? Why? Because you multiply this by 5 times 2, it's 10. Okay, so we say that, so the corresponding function value is z, so the corresponding function value is what? Is 10. Okay, so we say f of 5 is equal to 10, and 5 is 10. Okay, so basically that's what is going to happen. So when we say, for example, if we say again, we can say, in other words, we can give you an illustration. We can say y is equals to maybe 4x squared plus 2. Okay, this function at t, or maybe if we say then a, we say g is equals to 0. Okay, b. You can say g is equal to 2. Okay? So what we are saying is that there, you shouldn't be confused because we've changed g for x. Okay? What we are just saying is that it is the same idea. So you substitute this number, this 0 for x. So we are going to say, you're going to substitute this answer. So we're going to say, okay, let's make some space. Let's make some space. So if we say, so obviously our answer A, okay, these are solutions. Our answer will be f of 0 is equal to 4 squared plus 2. Okay, so there we're going to have that 0. We know that this is what? This is 1, 4 plus 2. So our answer will be 6, something like that. Okay, it should be similar to this. So any okay, there we get 0, we get 1 multiplied by this is 4 plus 2. Okay, so you can solve it and get your own answer, but this is a quick solution that we came up with. So of course B, okay, B is going to be so B is going to be f of 2 is equals to 4 there plus 2. Are you following? So we're going to say f of 2 is equals to 2 multiplied by 2 to the power 2 is what? Is 4. 4 times, so here when we have 2, the implication here is that we are saying 2 times 2. Okay? So 2 times 2 is 4. If you got 4 to the power 2, what we are doing is 4 times 4. Okay? Then if it's 3, they have to be 3 or 4, 3 of them. Okay? So that's the implication. That's what we mean when we say square. So here, this is 16, okay? Because there will be 4 times 4 is 16, okay? So 16 plus 2, what are we getting? F of 2 is going to be 18. As simple as that. So make sure you follow through examples in the module. In the module and the quizzes, you should be able to get some of these. And of course, our library, our e-library has got a module that I'm using to get some of these. So just go on the functions and find the book and be able to practice through, and you'll be good to go. So the library is made for you. You need to be able to use it. Okay, an online library is a very convenient way of working out. Okay, so that's what we have. So with that being stated, let's now go ahead and look at domain of a function. Domain of a function. Domain of a function. Okay, domain of a function. Okay. So, a function is a relation like we indicated. Okay, we've learned that a function is a relation and it is often necessary to determine its domain and its range. Okay, first of all, you need to determine the domain and the range to consider a function defined by equation. Okay, which is defined by y is equal to f of x. Okay, so the domain of f is the set of all x values that when substituted into the function produce a real number. Alright? So the range of f is set of all values corresponding to the value of x in the domain. So what we are trying to say here in simple language, okay, in simple terms, okay, is that you see the domain is the set of all numbers, all the numbers that all the numbers in x, when you put them or when you multiply them or you add them or you work them out, they'll give you answers in y. Is that clear? So you replace them from the equation and they'll give you, when you replace x, it will give you y. And when you replace y, it will give you x. That's what we're talking about. So the domain so to find the domain of a function, so if you've got a function that is defined by this, okay, to find these, we need to follow a few simple guidelines. To find this, we need to follow through simple guidelines. First guideline is that one, exclude value of x that make the denominator of a fraction 0. Okay? Exclude function, exclude, okay? Exclude values of x that make the function, that makes the fraction 0. Okay? So the fraction should not be 0. Number 2, exclude values of x that make a negative value within a square root. Okay? So exclude the value of x, that make the value negative value within a square root. So make sure you do not have something like this. Okay? We refuse. So in short, you shouldn't also have negative values. Okay? We refuse. So no negative values, no square root values. So make sure you run away from such type of function that give you such solutions. So let's look at an example. So if we say, okay, so if we say, so gt is equal to t squared minus 3t. Are you there? Okay. So what are the solutions? So when you look at this, we're saying that the function is defined by g. So the function, of course, in solutions, when you look at this function, okay, this function is defined by the same, has no restrictions. Okay, because any real number substitute for t will produce a real number. Okay, so when you look at this, equation, because they are positive, any value of has no restriction. Okay, because any real number substituted for t will produce a real number. So here, if we produce a real number, it will give us a real number. Real numbers are 0, 1, 2, 3, 4, 5, 6. Numbers that we use for counting. Okay, so those are called what? Real numbers. Okay, so we are going to say this number. If you substitute any, you can try to substitute any number. It will still give you a whole number, which is negative infinity and positive infinity. This is a real number. In short, it is not going to give you something like 1 over 2, okay, or negative 1 over 2, or positive 1 over 2. It is not going to give you something like something like this. So this has no restriction. This equation is clean. Okay, because of that, it is easy for you to write a domain function for this equation. Okay. It is easy to write a domain function for this equation. And to do that, you pick numbers, on the number line, and you should be able to solve this. So, so basically, that's that. So in today's lesson, we have defined, what a domain is. We've defined what a domain is. Definition of a function. We've looked at the function notation and how you can solve them, and we looked at the notation of the function as we said. Then we also looked at the domain. So make sure do not just depend on this. Next time you look at graph or function, do not just depend on this. Go and read. This is basic of the knowledge that we are giving you. Go and read more about functions, try to solve more questions, and you'll be good to go. Make sure you also solve the quiz that is there for you to be very competent at solving mathematics. Remember, mathematics needs to be solved every day for you to be able to grasp the concept exhaustively as a student. Thank you until we meet next time when we'll be talking about Unit 2, the next topic, which is graphs of functions.